You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, listeners, and welcome to the Common Descent Podcast. This is episode 156. It's a whole new year.
First episode of 2023.
2023, and we are starting it off strong. This episode's topic is Eurypterids, which you, dear listeners, may know better as sea scorpions.
Yeah.
Which, as it turns out, is not a good name for them.
Nope.
We will go into more detail on why that's not a good name for them in the episode discussion.
It's a very cool name, so I see why it caught on.
Absolutely. It's more catchy than Eurypterids, although I do like the word Eurypterids.
No, I think Eurypterids is a great name.
This episode, we will talk about these creatures. These are Paleozoic arthropods. They were very common in the seas back during the Paleozoic Era, such times as the Silurian and Devonian. They were a big deal in more ways than one. We will talk about what they are, what they looked like, how they acted, and what we know about their lifestyle, evolutionary history, and a few surprises along the way. Very cool group of critters that were requested. Just like all of our episode topics, this comes requested by our listeners. This particular topic was a popular one, requested by Ben, Johan, Lachette, Ali, Big Boss Man, IOC Electus, and Lucky Tomato.
Thanks for the requests.
Thanks, everybody. Hey, before we get into the main episode discussions, a few announcements. First and foremost, we have a Patreon. Supporters on our Patreon get goodies, including, at a certain level, getting your name shouted out in gratitude here on the podcast. And here at the top of the year, we would like to welcome brand new patrons Lucy, Judson, and Kleeman.
A good group to start the year off with.
Thank you for joining us and thank you for supporting us. Hey, it's a new year, which means it's a great time to remind everybody of all the different ways there are to get involved in and support this podcast. There's more now than there have ever been.
Yes.
This podcast is supported entirely by subscriptions on Patreon. Our patrons get access to us. They get the chance to submit patron questions. We do director's notes for each episode. We do bonus news and after chat for each month. Every month we have a live stream with our patrons where we interact with them. They get to ask us questions. Always a ton of fun. We have a Discord now with over 500 members, which is exciting for us, with channels and conversations devoted to art and wildlife and speculative evolution and our recent episode topics and all sorts of cool stuff like that.
We also do a Q&A every month on there.
We sure do, where people get to cue us.
For some A's.
For some A's. We have a merch store on Zazzle.com where you can get Common Descent themed merch. We are on the social medias, Facebook, Twitter, and Instagram. We have a YouTube channel where you can watch some other videos, but mostly listen to our podcast with a colorful background on them. And of course, if you check down in the episode description, in addition to all of those links, you'll find our email address for reaching out to us, our physical mailing address for sending us stuff. Speaking of which, we've gotten some more gifts recently. We got the other pack of Dinotopia cards from Katie.
Yep.
Thank you very much. And some great stickers from Amanda with original art.
Yeah, I have a trilobite.
Which is very, very cool.
It's very pretty. I'm really excited to find a place to put those.
Also down there is a link if you want to make a one-time donation to support our scientific communication efforts. And a link to Audible. We are part of the Audible Affiliates program, so if you go to audibletrials.com/commondescent, you can get a 30-day free trial and support us. We figure that if you're listening to this, you like listening to stuff that teaches you and entertains you. Audible is a great place for that. I very recently downloaded a book called Marvel Comics, The Untold Story, which I have had recommended as good, and I'm excited to start that. It'll probably be the first book I listen to in 2023.
Nice.
That'll be pretty cool. And finally, of course, the first thing you'll see down in the description is a link to our blog and website. After each episode, there is a blog post about the episode topic with links to the news and stuff. And if you go to the blog, you will notice a change. It is now officially commondescentpodcast.com.
Yes.
We have our own URL, our own domain.
It feels so fancy and adult and grown up.
So thanks again to all of our supporters for getting us to the point of being able to do that. We're looking forward to doing some, playing around with the new opportunities we have to mess around with the website format.
See what this allows us to do on there.
Also, one more thing, it is a new year, which means we just finished an old year, which means we released our end of the year Q&A for 2022.
Sure did.
We spent almost 4.5 hours answering your questions. Thank you so much for submitting those questions. If you haven't listened to that already, check it out, however many sittings it takes you to work your way through it. And other than that, stay tuned. The rest of the year, we're going to do stuff. We're going to have Silver Screen Science. We're going to have Spooky. Maybe we'll have some other new stuff coming down the pipe. It's an exciting time.
Yeah.
But that's enough about us. Let's talk about news.
The news.
Every episode, we start off by going over some recent news from paleontology and related sciences. In 2023, it is no different. Will, what is our first news of the year?
Giant crocodile.
Of course it is.
Yep. Start off the new year right.
All right, let's hear about this croc.
Get off on the right foot. This was a specimen that is a partial skull, but was misidentified as dinosaur and has recently been identified correctly as crocodilomorph.
Oh.
And turns out to be a big one, a big crocodilomorph. This research is by Thiago Fascini et al. In Historical Biology, and the article is by Vishwam Sankaran in The Independent. So this is a croc cousin, a crocodiliform, I think I said morph earlier, crocodiliform found in Brazil that dates to somewhere between 72 and 66 million years old.
Right, late Cretaceous.
Very late Cretaceous. This is from an area known as the Baru group, which has multiple fossil formations in it. This one specifically is from the Adamantina Formation, which is notable because other formations from this area are devoid of fossils such as this.
Oh, no crocs.
Yes, so this one's notable for where it came from. It is a large partial skull, mainly skull roof, it sounded like. Fragmentary, preserves the right side more so than anything else. So it is not a pretty skull, it doesn't sound like.
Right.
But it is a decently sized skull. It comes from a decently sized skull, the pieces we have. And because it was so fragmentary, it was hard to ID initially.
Sure.
And at first got put down as a partial titanosaur skull.
Oh, interesting.
Yeah, they thought it was one of the big long necks.
Yeah.
So they knew it was a big animal. More recently, it has been acknowledged that it is a crocodiliform skull, and this paper identified it as a new species, which they named Titanochampsa iorii. They were still able to note some things from the skull. It has ornamentation on the skull.
Oh, it's like little bumps and ridges and stuff.
Some sort of bumpy display, potentially. They noted that it was on the squamosal and the lateral corner of the skull where it was most notable.
In the back.
It is also notably pitted and grooved in certain areas, so it has some texturing to the skull, which is very typical of the overall croc group. They have very knobbly skulls. It possessed enough features for them to reject it as a Notosuchian, which we talked about the Notosuchians in the Crocs episode way, way back. This is just a very large group of extinct croc cousins that were very successful during times, but this does not seem to be one of those, which makes it which so far was the only group known from the Baru group.
Oh, so we got a whole different lineage of crocs in this area now.
Up till now, we had other Notosuchian crocodiliforms, but this seems to not be one of those, so it is something else. When they looked at it phylogenetically to try to figure out where it fell out, it seemed to have the most support to be within Neosuchia or Eusuchia, which is the group that includes our modern-day crocs.
Right. So this is potentially a closer cousin to crocs as we know them today.
Precisely. And the similarities potentially don't stop there. Based off of the estimates for the full size of the head, given what we typically know about the croc body shape, the total length of this animal would be somewhere between 3 to 6 meters. So a 10 to 20 foot croc. So not a small croc. This is a big size. That is the upper range for species today and is large just across the board. It looked like it had a very strong bite, and that, coupled with the fact that it seems like it's likely within Neosuchia, it's very likely that it could have had a semi-aquatic lifestyle.
Mm-hmm.
Strong bite is something that is often associated with the aquatic crocs, as well as that is a very common lifestyle in this group of crocs, the groups that includes all our crocs today that all live that way.
Yeah.
Which could be even further support if we find out that that is true to move it closer to Eusuchia. But there's no, from what it said, there were no key features that guaranteed it within that group.
Right. So exactly how close it is to our modern lineage of crocs is still unclear.
Yes. And a couple of pieces of evidence seem like it might have been living like or closer to the way modern crocs live.
Yeah.
But this is still a very fragmentary skull. This would also make it notable if it is semi-aquatic because predominantly the crocodiliforms from this group are all terrestrial.
Okay.
So if it is living like today's crocs, that would actually make it a weirdo.
Right. Not only a new lineage for this area, but a new lifestyle for this overall group.
And considering that we're at the in Cretaceous, they said that finding that info out could be very important for understanding the extinction trends and survival trends of crocs across the in Cretaceous.
Right. Did certain lifestyles survive better during the extinction event?
Precisely.
Well, that's a lot of fun information from part of a skull, as often happens. You know, croc researchers and paleontologists spend so much time trying to combat the idea that crocs have just never changed over time. And no, actually, they have evolved a bunch and they have come in all sorts of different forms. And then every now and then one of these comes along, which I can only assume is both exciting and a little bit exasperating to go, all right, that's true. But also here's one from the Cretaceous that might have basically been doing the exact same thing as crocs today.
Well, because the real issue with that whole conundrum and misunderstanding is that both are true.
Yes.
Crocs have not been static and unchanging. There's been tons of weird crocs, but also crocs have been crocs for a very long time.
The thing they do today that works so well, that has worked so well for tens of millions of years. So even as they experimented and did all sorts of weird stuff across the crocodiliform group, you could pretty much guarantee there would always be some that were doing the same thing as modern crocs.
Precisely.
Even if they were different species, living different ways, evolved different ways, they keep coming back to this tried and true approach.
Yep.
Well, my first bit of news has quite a lot in common with that story, although it will differ in an important way.
Oh, there's a twist.
This is also a new and kind of unexpected partial remains of an ancient predator, but in this case, saber-toothed cat.
Oh.
And then there's some more stuff going on with this cat. This is research by Caitlin Robb et al. In Papers in Paleontology, and the article we will link in the blog post is in The Conversation, written by Caitlin Robb and Alberto Vaquero, the authors of the paper, since that's what The Conversation does. These are newly identified fossil remains of a saber-toothed cat from South Africa. They were discovered in 2020, so quite recently, from a site called Langebonweg, or however you're supposed to pronounce that, located about 120 kilometers north of Cape Town. This is a partial skeleton. There's no skull. This is the postcrania, the things behind the cranium. The bones are quite large. They include vertebrae, so backbones, as well as hip bones and a bunch of the hind limbs. So partial back part of the skeleton of the cat. These are from the early Pliocene, around 5 million years old, which this area and this time are also home to other large carnivores. So one of the first things the authors describe having done is determining that this is not one of the other carnivores they find at this site.
That makes sense.
They've got early hyenas, they've got bears, and at least 3 other saber-toothed cat groups. Metalurus, Dinofelis, and Amphimacharidus all have been identified from here. And these remains, the authors determined, are not any of those things.
Cool.
This is something a little bit different. They did some anatomical comparisons to try to figure out what exactly they are, and they found that what they are most similar to is not the cats that are also found in this site, but saber-toothed cats called Macharidus, which is found in Spain, and Locotungulurus, which is from Kenya. Now, like I said, there's no skull, and as we've talked about on the podcast before, if you want to identify mammals, what you really want is teeth most of the time. So without that, they can't really get more specific. They don't give it a name. They don't identify a particular species. But it seems to be different from the other saber-toothed cats that have been found at this site before. Possibly a new species. And if it is related to those Kenyan and Spain cats, potentially a lineage of cats that not only hasn't been found here before, but hasn't been found in this part of the world. This is a range extension for that sort of corner of the saber-toothed cat family tree.
Yeah, that their ancestry comes from elsewhere.
Yes. However, if you see the headlines about this story, that's not what is featured in the headlines. What's featured in the headlines is that this cat had some problems.
Yep.
Across the skeleton, there are pathologies. So, signs of injury or disease. We did a whole episode about this, episode 84, with our friend Laura. If I remember correctly, they said in the paper that of the 19 bones they have, 13 of them have some sign of pathologies on them.
Wow.
The pathologies include erosion at the joints, including grooves that have been worn in by the friction of the bones. Also bony growths, exostoses, which can include additional little bony projections and bony spurs, and something called eburnation, which apparently is what happens when bone experiences extra friction or pressure. It will grow particularly dense bone growths in response.
Oh, yeah, to like reinforce itself.
I suppose so. All of these things are going on in the hips and the vertebrae in the feet, which the authors have interpreted as osteoarthritis.
Makes sense.
This cat had a bad case of arthritis, particularly, they noted, in the hind foot, one of the hind feet, and the lower back, which sounds like where you would get pretty bad arthritis.
Yeah.
This is interesting because, one, it tells us something about this cat and its life. They suggest that this is probably a good indicator that it was an old cat. This is something we see in age.
That's what I saw a lot of the headlines noting.
Yep. And that it was probably in quite a lot of pain.
Aww.
Poor kitty.
Aww.
This is also interesting because it raises questions about the lifestyle of this animal. This is a whole section of the paper is devoted to discussing what would this have meant for this animal's behavior. They compare with modern animals, and they actually, in the paper, they made a specific comparison with domestic cats, that we will see this kind of osteoarthritis in domestic cats, and it tends to limit their mobility. It'll change how they jump. So they might not jump on things as often, or they might not jump as high. These can be somewhat debilitating.
Yeah.
Which, for a wild carnivorous animal, would have impacted how it was able to hunt, how it was able to get around. And they actually go into a bit of discussion of this might have had a different effect on the cat depending on if these were solitary or group living animals, which is something we don't know about saber-toothed cats. We don't know if they were living like lions and having family groups, or if they were solitary like most modern big cats tend to be.
But we see that in modern animals, that solitary animals or social animals can fare better or worse depending on whether or not they can get help.
Right. They noted that if it were solitary, these kinds of injuries might have meant that they had to resort to scavenging or hunting easier prey. If they were group living, there is that angle of it maybe was able to survive better because it had a group that it was there to participate, so to help out. But also, social groups tend to have various status dynamics that an animal like this might have suffered in that regard because it couldn't hold its own in a group.
Yeah, it was going to eat last at every meal potentially, or something like that.
Things like that. Now, these are all things that we don't have answers to. Like, we don't know how they were living or what this animal was impacted, how exactly its lifestyle was impacted. But these are the kinds of cool questions that spin out of finding signs of injury or disease on fossil animal bones. And who knows, maybe in the future we'll find more evidence to help answer some of those questions.
Well, it's an interesting situation when we come up with discoveries like this, because as you said, we don't know what the lifestyle was like, but almost, or at least very, 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 very likely, these pathologies were affecting its lifestyle. Like, It's not, we don't see that in nature, that you get this many things wrong in your body and you just keep hopping along like nothing's happening.
Right.
You're going to have to adjust to the stresses of having that. So we now have that question in mind. And I like when we have these discoveries because it's a good reminder. It's very easy to forget to think about, okay, but what would this extinct, completely gone group of animals be like when they're old?
Right. Like this would be a large, and this is a large cat. They make that note. This is a big saber-toothed cat. This would have been a big, powerful predator that might also have limped a little bit. Yeah. And would have moved a little slower. Right. It had lower back pain. The actual lumbar vertebrae is where they noted the most pathology. This had lower back pain.
Yes.
This was a cranky old cat.
And so, like, we all know that has to be happening, you know, with the organisms from the fossil record. But I feel like it's very easy, especially when we do general portrayals, you know, in shows and documentaries and films, to forget that all the stuff that's happening with animals today would have been happening with those. They were getting arthritis. They were getting sore with age. They were getting old. I don't know. It's a nice reminder of that they were living lives.
Well, and it makes them in many ways more relatable.
Oh, yeah.
I can relate to lower back pain.
Yeah, sorry we didn't have ibuprofen yet, buddy.
I feel for you. Sweet. I say sweet kitty for this tiger-sized hypercarnivore.
Yeah, just paw. Well, I want to keep the predator trend going. Specifically, though, I still want to talk about aquatic predatory reptiles.
All right.
But there was no more croc news, so ichthyosaurs.
Oh, all right,
Ichthyosaurs. There has been news about a mass fossil assemblage of large ichthyosaurs.
Oh.
This research took stock of the types of individuals in this fossil site and potentially noted what it might mean for why these ichthyosaurs were gathered together. This is research by Neil Kelly et al. In Current Biology, and the article is by Carolyn Gramling in Science News. This is a well-known fossil site in the Luning Formation in West Union Canyon, Nevada, USA, the Berlin Ichthyosaur State Park.
Mm-hmm. I'm pretty sure we've mentioned this site
on
the podcast before.
So this is not a new discovery. That we've known of this fossil assemblage. It's from the late Triassic, 237 to 227 million years old. It is home to the world's richest assemblage of Shonisaurus popularis, which is a very large ichthyosaur, one of the largest ever known.
Yeah, Ichthyosaurs, episode 116, the shark-shaped giant aquatic reptiles from the Mesozoic. In that episode, we mentioned Shonisaurus a couple times because they are the record breakers.
Yes.
They get very big.
13 to 15 meters, so 40 to 50 feet.
Enormous.
Big, big, big animals. This fossil deposit would have been a previously tropical sea and just has so many, dozens of specimens of this large ichthyosaur, which has led to lots of questions as to why all the ichthyosaurs in one spot.
Right.
Like, why are they all here? Was this a mass death that killed a whole bunch all at once?
Right. Were the currents just dragging bodies here?
And one of the most potentially obvious answers is assemblages we see today in large marine organisms, which are mating or courtship or some sort of gathering, which we see in like whales and stuff that will gather together in groups to court, mate, give birth, whatever social thing they're doing. So they were wanting to look at what do we see about the individuals that we find here. And previous studies have looked into this. Most of them, it seems, focused on a concentration that was at least 7 skeletons that were closely grouped together in one single bedding plane, so one single layer of sediment. But there's a ton more than that in the site.
Mm-hmm.
They said across the 106 square meters and 200 stratigraphic meters, so depth at that point, they represent roughly somewhere between 1,000 to 1,000,000 years of sediment deposit, and at least 112 ichthyosaur individuals spread throughout that, many of which have been left in the rock, partially exposed as a visiting display for people to be able to come and see them in position. They said one thing that is notable here is, unlike many other marine tetrapod-rich deposits, this one is mostly just the ichthyosaurs.
Right.
They said
Not
almost
a big jumble of different things.
Yes, it's almost monotaxic. Basically just this
one
species. Which is weird. Usually you would have all the other stuff.
Right. Especially if you have a mass death assemblage or if it's a collecting point for the ecosystem for whatever reason.
You would expect all the other things that would have also been swimming to be preserved. They said other vertebrates are exceptionally rare. They also noted that this is a death snapshot. Many of them are preserved, articulated, and potentially in the position that they were next to each other.
Right. The whole skeleton is just laying there like the thing seemingly laid down.
And potentially even individuals next to one another, we might be able to get some behavioral info as to their positioning to one another. So they were looking at that. They used scanners to 3D model the still in rock specimens and get a positioning map for the specimens on the site as to how they are all placed among each other. They also looked at other bones from the museum collections and other parts of the park, and they found some interesting trends. One, it's mostly large individuals. They are very, very abundant of large, full-grown individuals, while lacking, it sounded like almost entirely, the intermediate-sized juveniles or subadults.
Right.
So big ones, and then not much smaller than that, except for a few very tiny remains. And CT scans of those fossils show that they seem to be embryonic or newborn.
Okay.
So they had large adults and bitty babies, and not much in between those sizes, which immediately gave them the idea that this was a birthing site. That the ichthyosaurs were gathering together to give birth, which we see in lots of marine organisms. They will find specific, either sheltered or more ideal places for them to give birth safely and do it as a large group. This has been proposed previously, but they said this is the first data to potentially...
quantitative analysis of it.
Yes. So this is really the first time we've had hard numbers to potentially support that. And if this is true, it would mean that this grouping behavior goes back at least 230 million years in vertebrates.
Yeah.
They also noted that it doesn't seem like it was a mass death because they find these specimens in multiple layers, that it seems like if it was a birthing site, but whatever they were gathering for, that they were doing it for a long time.
Right. Over and over again.
That since these specimens have been found at layers that include thousands to hundreds of thousands of years of separation, it doesn't seem like it was a mass death. There still could have been mass death events. They note that things like algal blooms, or one of the other ideas that was thrown out was like volcanic activity, could still have caused mass death events. But the researchers also noted that this could just be normal death rate.
Just collected in the same place over thousands of years.
Because if they were just coming back to this generation after generation after generation over thousands of years, there's lots of them are going to die from time to time, and that's just going to gather in that spot.
It's the kind of conclusion that isn't quite as dramatic as the tempting solutions of a big mass death event, but makes a ton of sense.
Oh, yes.
And it wouldn't surprise me if ichthyosaurs had specific places where they went to mate or to give birth, because like you said, a lot of organisms do that today. It's pretty common, especially in ocean organisms, that the ocean is not a safe place.
Yes.
Like, there's a lot of dangers. So having a safe haven area where animals are frequenting for whatever reason makes a lot of sense. I wouldn't be surprised if that kind of behavior goes back way before ichthyosaurs.
Oh, yeah, because we see fish do this. There's the famous salmon runs where they go to specific places. So, like, absolutely, this behavior, it's not surprising me that this behavior was potentially happening this far back in with this group. But it is very cool that the evidence seems to potentially strongly be pointing that way.
Yeah, and it's less dramatic than a big mass death assemblage. But I would suggest more interesting because it's more informative about the lives of those animals.
Yes, 100%.
Which is very cool.
I'm much more excited by this.
Well, it seems we've got a trend here with news about ancient predators. My last bit of news is not only about ancient predators, but about their ancient predatory lifestyles.
Perfect.
This is research about, now I'm going to say this, and you're going to think that maybe this isn't all that new or exciting, but apparently this is potentially the first time this has ever been found.
Oh.
a dinosaur that ate a mammal.
Yeah, that doesn't sound like...
We talk about that all the time.
Like, I mean, duh. Like, duh,
right.
that...
Of course they did that. This is mammal remains in the gut of a dinosaur, which might be the or one of the first times that's ever actually been found.
No, now that you mention it, yeah, I haven't... I haven't actually ever heard of research confirming that.
This is research by Dave Hone et al. In the Journal of Vertebrate Paleontology, and we will link to an article in Science Alert by Fiona McDonald. The dinosaur in question is Microraptor jowianus. Microraptor is a small species of theropod dinosaur, carnivorous dinosaur related to Velociraptor and friends. Microraptor is like raven size. It's a pretty small dinosaur.
They're cute.
This specimen comes from Liaoning, China. This is the Jeholbiota, which we discussed in episode 152. Early Cretaceous, 120 million years old. There are multiple species of Microraptor. This specimen is actually the type specimen of this species.
Oh, wow.
So it's the reference specimen, though the specimen, the particular specimen the species was named off of.
Yes.
Inside the body cavity, where you would expect to find gut remains, is the articulated, so mostly intact, foot of a mammal. A little mammal foot, a little paw in there.
So somewhere there is a little mammal with a peg leg.
This is not the first time guts contents have been found in Microraptor. We've talked about this before. Previous Microraptor specimens have been found with their guts including fish, birds, and lizards. This is the first time mammal remains have been found in Microraptor, and I have seen a few places claim this is the first time that we have had direct evidence of a dinosaur eating a mammal. That wasn't mentioned in the paper as far as I saw, so it's certainly rare at the very least. Wow. Also, the article claims that this is the 21st known example of carnivorous dinosaur gut contents.
Huh.
That there are now 21 examples of carnivorous dinosaurs with gut contents. I also don't know where that number comes from. They quoted some of the authors, I think, saying that, so it's probably true.
Yeah.
So yeah, less than 24, if that is to be believed.
I can't tell if that's less than I should have expected or if that's reasonable.
Yep.
Like, I'm realizing I don't know.
Gut contents are rare.
Yes.
They are rare to find, and yet we've got a whole bunch of them.
Weird.
So this Microraptor ate at least part of a mammal. The foot in question is about 1 centimeter long.
Cute.
Very well preserved. Most of the bones are there. It's mostly still in the shape of a foot. It includes all of the tarsals, so the ankle bones, all of the metatarsals, so the foot bones themselves between the ankle and the toes, and most of the phalanges, the toe bones.
All right. Cute little toe beans and all.
They also mentioned in the paper that there are pieces of what might be leg bones in there as well. So they didn't just nip the foot off necessarily.
There might be more of...
There might be more mammal in
the leg.
They compared it to other known mammals from around this place and time. Specifically, they mentioned Eomaya and Sinodelphus, which were both rodent-like, small. They weren't rodents truly back then, but they were rodent-like mammals. This foot seems similar to those, but they make the point that the shape of the toes seems more like what you'd expect in a terrestrial mammal, a mammal that was mostly running around on the ground. Those other two were tree dwellers.
Okay.
So this possibly isn't those. Now, with just a foot, who knows what it is? They did not identify a two species or anything, but suggests that it was different from the other mammals they compared it to, and potentially found on the ground.
Yeah.
And this is important for considering Microraptor's predatory habits. Mm-hmm. Not only does this give us insight into the variety of prey, this is now 4 different major groups of animals that have been found in the stomachs of Microraptors. So clearly they were feeding on a variety of prey, but also where they were getting their food. Mm-hmm. The study that described bird remains in the gut of a Microraptor specimen suggested that Microraptor might have been good at hunting in trees. The study that described fish remains in the gut of a Microraptor suggested that they might have been good at hunting in the water. This paper points out that they might have just been generalists.
Yes.
They might have been, and then they could have been scavenging some of these remains. They could have been hunting some of these remains. That this, funnily enough, tells us possibly less about their hunting habits, but more about just the generalized nature that they would potentially just be eating a variety of different things.
Well, I always have that thought a little bit when gut content comes up, and it's, animals. There's another animal inside an animal. And the urge to want to say, oh, okay, so they were hunting those things. And then in my mind will flash one of those videos that you'll see randomly on the internet of a squirrel tackling a bird.
Right.
Or something. It's like, all right. Or maybe that bird happened to land on the rock next to the Microraptor.
Right.
Because the bird was not paying attention for some reason, and the raptor went, oh, lunch, and jumped.
Or it could be scavenging.
Or it could be, finding dead stuff.
You don't have to go into a tree to get a bird if it falls onto the ground. So, like with the ichthyosaur thing, interpreting a generalized diet is less dramatic and exciting than a specialized hunter of bird or fish or whatever, but potentially more, or at least as interesting, to interpret a dinosaur as a generalized carnivore.
Yeah.
The paper points out that generalist carnivores are very important in many modern-day ecosystems because they eat a variety of things. They have particular interactions with a whole variety of different other animals living in their ecosystem. Generalist carnivores, I think the article called them stabilizers.
Yeah.
For ecosystems. But that can be really hard to identify in fossils. They make the point this might be the first time a dinosaur could be identified as a generalized carnivore, especially leaving out modern day birds.
Yes, exactly.
And they even make the point in the article in the paper that several other similar dromaeosaurs have also been found with a variety of different prey items. It could be that this was potentially a not uncommon thing for small predatory dromaeosaur dinosaurs to be generalist carnivores, just sort of setting a nice foundation for the predatory ecosystem in a particular environment.
Which we see tons of with today's small predators.
Mm-hmm.
There's tons of them that are just, if it can fit in my mouth and I can catch it or find it, I'll eat it.
Yeah.
That's a very common thing. But it makes sense that it is not intuitive to identify because by the lifestyle and adaptation of a generalist, you are nondescript.
Right.
You are not specialized, so you do not have an obvious feature that fits into a particular puzzle piece slot that we're looking for because you can eat pretty much whatever you want.
And given how rare gut contents are, it is much more common that we're going to find one specimen with one thing in it, and that's going to skew our understanding of what they might have been feeding on.
Yes. It's also particularly funny to me that we published evidence of mammals eating dinosaurs.
Yes, we did.
Before, that's super weird.
Yep. Yep. And it's funny because it's one of those things, and we've talked about these before, where we knew, in quotation marks, that this happened.
Yes.
Because you had large to medium to small size predatory dinosaurs and small mammals. Certainly.
Yeah.
Mammals were getting eaten by dinosaurs. So this is not at all surprising, but it is very nice to have a little piece of confirmation that, okay, this did actually happen at least once.
Yes.
There was, as you said, a peg-legged little rodent-like mammal just running around grumbling about that one time.
I want paleo art. I want fan art of that.
Well, listen, I want the cranky, large saber-toothed cat with lower back pain, and I want the peg legs, little mammal.
They can be a team. The scrappy little fighter and the grumpy old cat.
Well, that's the news, but wouldn't you know it, our trend will continue because for the whole rest of the episode, we're going to talk about a group of marine carnivorous animals.
Excellent.
So we got a whole lot more to talk about. After the break, we will start our main discussion about Eurypterids, aka sea scorpions. And the first couple of questions we're going to answer are, number one, why is sea scorpions not a great name for them?
Mm-hmm.
And number two, and this is important, what in the world is a Eurypterid anyway? Because you might have an image in your head, but they are weird animals.
Yes.
They are not quite like anything today, so we're going to start off by giving some description. Stay tuned for that. When we look back to life of the Paleozoic era, there are a bunch of familiar things. Early fishes, and on land you've got trees, and you've got, early lizard-like things in the later part of the Paleozoic. But the Paleozoic is home to a ton of totally bizarre extinct groups. Trilobites were back then. We did an episode about them back in episode 82. You've got your big nautiloid cephalopods. You've got all your weird Cambrian stuff. One of the most famous and recognizable groups of totally extinct Paleozoic things are Eurypterids.
Yeah.
Eurypterids are AKA sea scorpions. This is a bad name for them, catchy as it is, because they are not scorpions. I think it was thought in the past at certain times that they might be closely related to true scorpions.
Yes, I do believe, I remember seeing that description in old, a verbiage about them.
But they are not scorpions, and also mostly didn't live in the sea.
Which is...
As it turns out.
The first time I learned that blew my mind.
Yeah! We think of them as these ocean-dwelling creatures. Eurypterids are aquatic arthropods. These would have lived in water, in aquatic environments. They do look rather scorpion-like in terms of their just general body shape. That would have been found swimming or crawling around bodies of water throughout most of the Paleozoic era. Now, they're not scorpions. What they are, at least this has gone back and forth over time, current evidence suggests that they are chelicerates. Mm-hmm. So this is the group of life that includes arachnids, scorpions, spiders, and all of their cousins, as well as horseshoe crabs. Mm-hmm. In the past, it was regularly suggested that they might be very close cousins of horseshoe crabs, and they're often compared to horseshoe crabs for lifestyle and ecology. But the most recent studies place Eurypteridae, the group that Eurypterids belong to, as sister to arachnids.
Okay.
As the closest major group to true arachnids. And then horseshoe crabs are a little bit farther down the line, a little bit separated from that.
All right. Interesting.
So Eurypterids are probably not scorpions and not particularly closely related to scorpions, but not all that far from true scorpions.
Yeah.
Which are within arachnids.
They're closer to scorpions than horseshoe crabs are, but They're still pretty far away.
But still, spiders are closer to scorpions than these things are. So Eurypterids are chelicerates. They're in that sort of corner of the arthropod family tree, as opposed to the other sides of arthropods where you have insects and crustaceans. Those are separate. Now, there's a lot to say about Eurypterids, but because Eurypterids are weird, and because if the image in your head is a scorpion, it's not quite accurate.
It's going to be you're going to be trying to put the wrong shape to the rest of our descriptions.
I would like to spend some time talking about the anatomy of Eurypterids. What do they actually look like? What are their body parts? Let's lay the foundation for understanding these cool aquatic arthropods. As you'd expect from arthropods, Eurypterids have a chitinous body. They have an exoskeleton, like scorpions, like spiders, like insects. Eurypterids have two main body sections. Also, like, spiders. Mm-hmm. Spiders have a head and then a big body. Eurypterids have essentially the same thing. A prosoma, which is essentially the head, and the opisthoma, which is the body or abdomen. Now, in terms of overall body shape, go ahead and picture a scorpion, and then we're going to modify it.
Yes.
We're going to tell you where the differences are. Starting with the prosoma, up at the front of the body, the smaller portion of the body. They don't have a little pinch like sometimes you see in spiders. The head section just melds nicely into the rest of the body. The prosoma has the mouth parts, where it would eat, eyes, and appendages. The descriptions that I've read of Eurypterid eyes describe one pair of compound eyes and a pair of ocelli, which are simple eye-like organs, which I think some of the eyes in spiders are technically ocelli. These are able to sense light, but they're not true eyes the same way that the compound eyes are. Eye placement varies in Eurypterids. In some, the eyes are facing more upwards, more dorsal. In others, they're more sideways, so there is variation. The most prominent feature of the head section of Eurypterids are their appendages. Mm-hmm. There are 6 pairs of, let's call them limbs, appendages, on the prosoma, this sort of semicircular portion of the front of the body, 6 pairs, 12 appendages. The first pair are the chelicerae. This is a feature of the group Chelicerates. This is what in spiders and scorpions are the fangs. Mm-hmm. So spider fangs are not teeth. They're not even really mouth parts the way the rest of their mouth parts are. These are an extra pair of appendages called chelicerae.
Yeah, they're arms with spikes on them.
Right.
The mouth's behind that.
Scorpions, same thing. They have these little fangs that are their chelicerae.
And theirs look like itty-bitty versions of their claw. They have teeny tiny scorpion claws in front of their mouth to not chew, but tear up and put into the mouth.
Yes. In Eurypterids, the chelicerae are also used to process food, get food over into the mouth. They come in a variety of different sizes and shapes. They are often very mobile. They're often spiny. Often they're grasping. They're able to move and process food the way that we see those fangs. And in some cases, Eurypterid chelicerae can be rather large, ranging from kind of big to, really big.
Yeah.
And sometimes they are claws.
Mm-hmm.
Sometimes they are adapted into big, grasping claws.
Big, meaty claws.
Whereas scorpions, true scorpions, their claws, their pincers are actually their second set of appendages.
Sure are.
In Eurypterids, it's the ones that have them, it's the first set. It's the chelicerae.
Yeah, so like when you look at a scorpion, the mouth parts are claws, and then their first set of next limbs after that are claws. The claws on sea scorpions would be those mouth parts.
Yes.
Which is...
The scorpions did it with the second pair.
Yep.
Eurypterids did it with the first pair.
Which is super weird, because on some of these, if you see pictures, they look like big old giant scorpion claws.
Yep.
But those are that first mouth parts.
Yes. So the size of the chelicerae and the shape of them vary quite a bit. The other limbs, the next 5 pairs of appendages sticking off the head section, are generally for locomotion. They come in varying sizes. Sometimes they're spiny and are also used to help gather food. These appendages are where we see one of the major differences between the 2 major groups within Eurypterids. The Styloneurina is the less common group in the fossil record. Their appendages, their legs, tend to all be good for walking. Sometimes they're short, sometimes they're long and actually quite powerful, like they're like a crab's legs.
Weird.
But they tend to be good walking appendages. The other major group in Eurypterids, the Eurypterina, also have good walking and crawling and scuttling legs. But in that group, which is the majority of known Eurypterids, the 6th pair of limbs, the last pair of appendages, are adapted into a paddle.
Yeah.
For swimming. This is similar to what we see in crabs. Some insects, like water boatmen, have this, where at least one pair of legs is flattened like a paddle for swimming around.
And these look like a boat paddle, like a boat
They look like an oar.
Yeah.
And these vary. So these vary in size, they vary in their particular shape, because this is a group with a ton of diversity. But this major branch within Eurypterids all have that 6th swimming leg. So already we're seeing different specializations in walking around versus swimming around. So that is the head. That is the first section of the body. Mouth parts up where the mouths are, couple pairs of eyes, and then 6 appendages that are for feeding and getting around. They do not have antennae. Chelicerates don't have antennae. These are limbs, appendages for other purposes. All of that is crammed right up at the front. That is the front section of the body. The second section of the body is the opisthoma. This is the rest of the body.
Yep.
And if you think of your Eurypterid with its head up at the front, like a scorpion with all its important bits up at the front, and then this long segmented body that's wide in the middle and then narrows toward the end, Eurypterid opisthoma, the body of the Eurypterid, is very much like that.
Which can be kind of weird because all the limb bits are up on the front. That is the headish bit.
The head, so to speak.
So it doesn't separate the way we would think a body would typically, but yeah.
So, like a modern day scorpion, the second section of the body is this long, segmented, tapering off shape. I found one reference that said that Eurypterids opistoma always has 12 segments.
Oh, weird.
It could very well be that there's some weird ones out there. I'm always a little hesitant to say all of them had
always this number.
Right. Never more. Never more than 12.
Never more, never less. But like the fact that that's a trend is interesting.
Yeah.
Huh.
The opistoma, the most of the body, most of the bulk of the Eurypterid, is where we find the gills, the genitals, the digestive system, all that stuff.
This is also true for like spiders. Like the bulb at the back is where their actual guts are.
Yes. And modern true scorpions, that long tapering body that we think of as tail or tail end body or however you imagine it, is where all the guts and stuff are. And then way down at the end of the tail. Tail is such a weird word to use for these animals.
It's not a tail like we talked about in the tails. It's not a tail like a vertebrate tail where it is a distinct it's the back long part of the gut-filled part of the body. We talked about this in the tails episode 151. But way down at the end of the tail of the Eurypterid is a final section called the telson. In some species, this is flat and paddle-like, presumably for helping with swimming. In others, it is what I have seen described as styloform, which means pointy. Yeah.
It is a little spike at the end. There has been much discussion over the years of whether they were using that little pointy bit at the end for some sort of aggressive behavior. I have seen artwork of Eurypterids arching their tail up over and in front like modern scorpions, although I do not think that is something that it is generally believed that they could actually do.
No, from what I've heard, the upward flexing is pretty much all an old idea now.
There has been some suggestion that they might have had lateral movement. They might have been able to move side to side and maybe poke things with their pointy telson, although that has also been questioned.
Yep.
So whether or not they were actually poking things with the little pokey bit way at the end is quite unclear.
Yes. Well, it makes me think of horseshoe crabs, which have a long, spiny, pointed telson coming off the back that people always look at and immediately assume must be like a stingray tail.
Right.
Because they're kind of stingray-shaped, a round part up front with a long part at the end. And it's not. It's a kickstand to help them roll over when they get on their back. That's all it does. It just looks threatening.
So this is the general shape of a Eurypterid, the head up front with eyes, mouth parts, and 6 pairs of limbs, and then the long segmented rest of the body where all the other stuff is. That is the general image, but this was a diverse group. There are, from what I've read, around 250 known species of Eurypterids. So there's all sorts of differences. Some of them have wider versus slenderer bodies. The shape and size of the chelicerae will vary. Like I said, the telson can be pointy or flat. The legs, sometimes they're short, sometimes they're long, sometimes they're relatively weak, other times quite powerful, sometimes they're spiny, other times they're not spiny. There's all sorts of variation in the Eurypterid body style, and also in Eurypterid body size. Most Eurypterids were small. A couple references I saw cited that most Eurypterids would have been under 20 centimeters. That's about 8 inches. So we're looking at half a foot long. That tends to be the size of most of them. The classic Eurypterid, like the the classic image of a Eurypterid, is the genus Eurypterus, which is commonly found, in particular here in the US. These are typically 10 to 20 centimeters long. They have big swimming paddles and a pointy telson down at the end of the tail. So we're looking at a group of animals that are going to be generally comparable in size to like shrimp and lobsters and things like that.
These could mostly fit inside shoeboxes.
Sure.
Yeah.
The very smallest Eurypterids, one that I saw mentioned in this regard is Alcanopterus, was 2 centimeters long.
Aww.
Full size. So like now actual scorpion size. Very tiny little creatures.
That's adorable.
Very tiny. And then on the other side of the spectrum, the largest Eurypterids were the biggest arthropods of all time.
Ever.
The biggest crustaceans, insects, arachnids, myriapods, millipedes and stuff. Eurypterids take the prize for the largest known arthropods of all time. The one that you will see cited as the biggest is Jekyllopterus, often cited as number one, which has been estimated to reach full sizes of about 2.5 meters long.
Yeah.
That is an 8-foot-long arthropod.
That's big.
These were enormous. And there, as we'll discuss this later, there were multiple groups that got that big.
Yeah, this wasn't a one-off weird species. They got big.
So Eurypterids not only vary in sort of body style and shape, but their size range goes from 2 centimeters to 2 meters. This was a very diverse and varied group.
That sounds like just a typo happened at some point.
Right.
You didn't hit the C, and you put 2M, and they went, okay.
Someone messed it up. No, we've got some big fossil specimens. So like I said, about 250 species. Some of those species are known from tons of specimens. The Eurypterid fossil record, there are plenty of Eurypterid fossils known. Mainly they are known from Lagerstätte. Very nicely preserved, exquisitely preserved fossil sites. Outside of that, I have seen studies describe them as having a fairly incomplete fossil record, in part because they have an exoskeleton. Their cuticle, sort of the outer layer of the body, is relatively thin and unmineralized.
Okay.
So versus something like trilobites, where they have sort of calcium minerals worked into the cuticle, Eurypterids don't have that. So they're more like, and I don't know the details of spider anatomy, but I assume like spiders.
Yeah.
Like those are not calcified outer coverings or anything like that. So they don't fossilize particularly well.
Interesting.
As I mentioned, there are 2 major groups within Eurypterids, Eurypterina, which are often interpreted as swimmers. They've got those paddle legs, and Styloneurina, which don't have those paddle legs and so were walking instead. Eurypterina are about 3 times more common than Styloneurina, which has led to the suggestion that Eurypterids were mainly swimming animals. Although one reference that I found said that the walking Eurypterids show a lot of diversity in their general anatomy, so it's possible that they are more diverse than the fossil record is showing us, or at least more numerous than the fossil record is showing us.
Yeah, that we don't have as many of them, but what we do have, there's a bunch of different kinds.
Right. But swimming lifestyle seems to be the most common one for Eurypterids. The most common Eurypterid, period, is the genus Eurypterus, which was the first one named. They are known from the Middle to Late Silurian, and they make up, according to one reference I read, about 90% of all Eurypterid fossils are this genus.
Yep, that's a pretty hefty lead.
So it's possible we have a skewed perspective on the diversity and distribution of Eurypterids. Eurypterus is, like I said, the quintessential example of Eurypterids. Eurypterids have been studied scientifically for quite a long time. The first Eurypterid specimens to be described were named in 1825. These came from New York, which still to this day is a famous place to find Eurypterids. There's some great Eurypterid fossil deposits in New York. Those first specimens were Eurypterus, specifically Eurypterus remipes, a famous Eurypterus species, which is the state fossil of the state of New York.
Oh, yeah.
It was the first state fossil I ever learned about, because that's where I grew up. The name Eurypterus means wide wing, which refers to the broad sections of the body. And this is all a decent representation of the kind of places and ways and times we find Eurypterids. Eurypterids, like I said, generally found in various aquatic habitats, exceptional fossil sites, particularly in the Silurian and Devonian periods. The oldest known Eurypterids come from the Middle Ordovician. There's actually a study in 2015 that described the oldest known Eurypterid from Iowa, which puts it at Middle Ordovician, around 470 million years old. On the other end of the spectrum, there was a 2021 study that described the youngest known Eurypterids from Queensland, Australia, which are right at the end of the Permian, just before 250 million years old. So Eurypterids were around for 200 million years of time. They were most diverse in the middle, during the Silurian and Devonian. Eurypterid fossils are found on every continent, but the majority of them are in the north. North America and Europe, which at the time were connected. And part of this could just be bias in the fossil record sampling, that more research and excavation has been done in the north. but some studies suggest that it does look like Eurypterids were more diverse and common in the northern continents. This might have been due to limitations in how much they could spread around the world. They might have been dispersing mostly around shorelines, not crossing oceans.
Yeah.
So Eurypterids are found across a wide span of time. They are found all over the world, but mostly in the north. They have a great fossil record at particular kinds of fossil sites, and they are also found in a variety of ancient habitats. Like I said at the top, Eurypterids were mostly not marine organisms. They were mostly not living out to sea. Most Eurypterid fossils are found in brackish water, so that is, salty-ish water.
Yeah, a mixture.
Lagoons or other shoreline environments. Some are found in more ocean settings, and a lot of them are found in freshwater environments. Rivers and lakes. So this is a group of organisms that ranged from true fresh to true saltwater environments.
Which does make sense. I mean, we see that
Sure.
with the other aquatic arthropods. So that's not surprising.
Yeah,
But
crustaceans do that. We see a lot of groups that do that.
But just that's not what you typically hear talked about with this group.
Yeah, well, it's like a lot of modern aquatic arthropods. We think of them as being ocean creatures.
Yep. Like when you say crab, a lot of people immediately are like, yeah, at the beach.
Yeah,
And,
in the ocean.
But there's swamp crabs and lake crab, like crabs that come right up into fresh water and cannot do salt water.
Yes. So yeah, swamp Eurypterids surely existed.
Cool.
And then there has also been tons of conversation back and forth about Eurypterids over the years as to how much of their time they might have spent out of the water.
Mm-hmm.
This is a big discussion surrounding Eurypterids. Could they walk out of the water onto land? And if so, why? And if so, how capable were they? It's been suggested at various times that they may have left the water. They have those legs for walking. Some of them have quite powerful legs, kind of like crabs. We see a lot of aquatic arthropods do this today. Crabs are a great example. Yeah. They leave the water and go venturing elsewhere.
Horseshoe crabs.
Horseshoe crabs do it. It's been suggested that Eurypterids might have been able to leave the water either to feed, right, to get food, to scavenge on the beach or something, to move from one body of water to the other, or even to reproduce.
Yeah.
Horseshoe crabs do that. They crawl up onto the beach to mate and lay eggs.
And get it out of the way of aquatic predators that they're typically living with.
All the things that can't leave the water.
Yep.
Now, the question of whether Eurypterids were capable of and in the habit of crawling out onto land is largely tied to questions about how they lived their lives, how they got around, how their bodies worked, what they were able to do. So we will continue to return to this subject of possible terrestrial Eurypterids as we move on to discuss what we know about the lifestyles of Eurypterids. What were they like ecologically? After the break, stay tuned. So since I started talking about questions about how Eurypterids got around, let's start by talking about how Eurypterids got around. There's been quite a bit of research dedicated to Eurypterid locomotion. Like I've said, most known Eurypterids were predominantly aquatic. They are found in aquatic environments, in lakes and rivers, ancient shorelines, things like that. And most Eurypterids had those swimming paddles on their last pair of legs. Exactly how they swim has also been discussed, how they move their flippers and such. Apparently, one thing that I read pointed out that there were early suggestions that Eurypterids might have flipped over and swam upside down.
Oh, because horseshoe crabs.
Yes, young horseshoe crabs will do this.
Yeah, I've even seen some bigger ones do it at the aquarium if they get, knocked up by a jet or caught in a current, I assume. They will start paddling like a young horseshoe crab until they can get somewhere and right themselves.
This doesn't seem like it's something that is thought was particularly common with Eurypterids, but since horseshoe crabs can sometimes do it, especially when they're young, maybe Eurypterids did too.
Yeah, which is, that sounds like a super weird thing for a predominantly, or at least the ones that seem like they were predominantly swimming, for a predominantly swimming group to do, but also not that super weird.
No. What does it matter? You're in the water.
Yeah, like flounders swim sideways, so how that's not that weird.
So a lot of Eurypterids were adept swimmers. It doesn't seem like a body shape that's necessarily, it's not like shaped like a fish, but like lobsters, like crabs, like horseshoe crabs, they were moving themselves around. They were active swimmers in the water column.
And I think that's something that I know that the first time I really was introduced to Eurypterids, had that moment of like, but how are you moving? You don't seem...
Right.
The parts of you that seem like you should be swimming one way don't actually seem like they're then shaped to be swimming that way, or blah, blah, blah. But then you get things like swimming crabs, which, if you don't know better, just look like a normal crab, except the back two legs...
Until they start swimming.
have big paddles, and then they can just motor through the water. Like, they can outswim some scuba divers.
Yeah.
So you don't need to be shaped, quote unquote, good for swimming to be good at swimming.
Yeah, I'm not.
No.
Of course, Eurypterids are also walking, like those comparison animals. Most of them had relatively short legs, which you can picture them scuttling along under the water. Certain groups had rather large or robust, or even in some cases stilt-like legs.
Weird.
And again, think of like a crab.
Yeah.
Bigger legs that are able to get them around more powerfully. These are some of the species that have been pointed at potentially those might be the kind of legs you'd use to walk around out of the water.
Yeah, those seem like legs that should be able to handle gravity.
Yes. There are also a number of trace fossils of trackways from Eurypterids. I have seen references in specific papers for trackways from Scotland and the United States and Canada. Wikipedia says... asterisk, Wikipedia, that trackways of Eurypterids have been found on all continents.
Okay.
So they are, at the very least, they are pretty common. We have quite a number of trackways of walking traces from Eurypterids. These are typically the traces of the legs, right? We've talked about trace fossils, episode 118, of footprints and walkways, pathways. Typically, these are walking traces underwater. Often, when I was looking some papers, and I looked specifically because I was curious, often with a drag line for the telson, or the tail, dragging along behind them. I have seen some artwork of them holding up the back part of their body, so maybe they weren't dragging it all the time. I don't know how much actual research has gone into determining if they were holding up the back end of the body or not.
Their posture while walking.
Right. There was a 2017 study that described swimming traces from Eurypterids. This was from a Silurian site in Pennsylvania. Actually, two sites, one in Pennsylvania and one in Ontario. These were traces made by that last pair of limbs, the paddle limbs.
Ooh.
And in the paper, they also they go into a lot of detail describing what does this mean for how they swam. And they talk about sort of the rowing motion that is inferred for how those paddle legs would have moved.
Okay, cool.
And there is a 2005 study that I found that is a trackway, a walking trackway, interpreted as Eurypterid walking track in Scotland in a land environment.
Oh.
That this seems to be a Eurypterid, and it seems to not have been underwater.
I think I have heard of this.
This is trackway evidence of at least one Eurypterid going for a walk out of the water. It is also a big trackway. The trackway is about 1 meter wide, and it has been suggested to belong to a genus of Eurypterid called Eurypterids, which is one of the biggest Eurypterids known.
Wow.
The paper describes that this trackway seems to have been made by a Eurypterid with relatively short legs and a slow gait. That this thing was just slowly moving itself across the surface.
Dun, 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 dun.
So, back to that discussion about land locomotion. Most of our evidence is them moving around in the water, but there seems to be some decent hints. And if that trackway is actually Eurypterid trackway, then yeah, that is at least direct evidence of a Eurypterid moving over land.
At least one time, one individual of this species came out to the surface.
Yes.
Which also, when you said big, I was like, A foot across would be that'd be big.
No. A meter across.
A meter across? If I found a meter across trackway on the beach today, I'd be uncomfortable.
Like sea turtle trackways are a meter across.
That's so big. It is so easy to forget how truly big the big Eurypterids.
Oh yeah, 2 meters is 6 to 7 feet, and some of them might have been bigger than that.
Yep.
Like it is big.
Well, and I also wasn't expecting one of those to be the potential solid evidence.
Yeah.
I was like, surely if it's one coming out, it's like a little small but robust.
Like a crab.
Yes.
Well, crab walking one.
You don't see Japanese spider crabs coming out onto the beach because they can't do that.
Right.
But the ones we see on the beach are little fiddler crabs, not necessarily itty bitty, but smaller.
This was a big one.
And now I'm picturing it dragging itself like a sea turtle. Just oh, creepy.
Now, another aspect of Eurypterid life that is related to the question of water and land motion and also has been the subject of lots of discussion is how they breathed, their respiration. This comes up with the terrestrial locomotion question because breathing in the air is different from breathing underwater.
Very.
We do know a bit about how they breathed because we do have fossil evidence of their gills. These are a type of gills that are called book gills.
That's what I was expecting.
Yeah, which are... And why were you expecting them, Will?
Because that's what horseshoe crabs have, and spiders have book lungs.
Yes, absolutely. Book lungs is what we see in arachnids. Book gills is what we see in horseshoe crabs. Book gills have been interpreted as being ancestral to book lungs.
Yes, which makes complete sense.
Absolutely. Certain Eurypterids have been described as having structures in their gills, pillar-like structures called trabeculae, which provide extra support. If I remember correctly, they provide extra support to strengthen the gills, which is something we see in species that can breathe in the air.
Okay, yeah.
That this helps them to function in water as well as in air.
Makes sense.
Eurypterids also had special organs on the underside of their body, which are called chimenplaten, or however you're supposed to pronounce that, which are sometimes also called gill tracts. And this is separate from their gills, so they have a 2-part respiratory system. These gill tracts organs have been described as being similar to the lung-like organs of certain crabs, which they use to breathe air.
Yeah.
So in terms of their respiratory system, there are multiple lines of evidence to suggest that Eurypterids were at the very least capable of breathing air as well as breathing in water.
If you were to have picked one up out of the shore and held it up in the air, it wouldn't have just immediately started to suffocate.
Right.
They're
like a horseshoe crab.
Yes.
You can do that and it's going to be okay for a while.
Yeah, and they can't just do that indefinitely. Like horseshoe crabs have a limited time they can be out on the beach, but they can hang out there without just immediately starting to die.
Right. Now, it's always difficult to separate the question of whether a particular organism could do something from whether it did do something. There's tons of reasons you can imagine for why it might be beneficial for an animal to be able to move over land, even if that's mostly not where it is. Because water moves and the rivers and lakes dry up and tides come in and out. If you're living in shoreline or freshwater environments, it is not outside the realm of possibility that you might end up on dry land by accident.
Yes.
Or get forced onto dry land. So it's totally possible that they were able to go up on land, just in case, just for if it happened to happen.
Well, and especially with you noting that a bunch of them were found in intercontinental freshwater, where you can get in isolated pools more often than you're going to get out in the ocean.
And when it can be beneficial to be able to move from one pond to the next.
Yep, so that would make complete sense in those environments, especially.
But there is, of course, another angle. As we've been comparing them to horseshoe crabs, as researchers often do, and like we mentioned before, horseshoe crabs come onto land to reproduce. This has been suggested as well for Eurypterids. We do actually know a little bit about Eurypterid reproduction, because, like the gills are preserved on the opistoma, the genitals are preserved on the opistoma of well-preserved Eurypterids.
Right.
And these have been compared. So the features of the genital structures have been compared to other arthropods. And there have been papers that have noted that they have certain structures in the genitals interpreted as being similar to the horn organs found in modern arachnids. These are interesting because, one, they're sexually dimorphic.
Okay.
They're different from male to female, so they are a potential source of identifying the sex of the ancient animals. But also, in arachnids, these are used for carrying spermatophores, which are packages of sperm.
Yes.
Which those kinds of animals will deliver a package from male to female. That's how they are delivering the sperm from one to the other, as opposed to internal fertilization or spawning, like some fish do, things like that.
Yeah, which is always can be a very odd way to think about mating, in that literally the male just gives the sperm.
Yeah, here is a package.
Yep. Do with it what you will.
Inside you will find my progeny.
Yep.
This suggests that Eurypterids might have been using spermatophores to transfer sperm the same way we see in those modern animals. This is interesting because it suggests, number one, that like we see in modern arachnids and similar organisms, females might have been able to store up sperm, allowing them to control the timing of egg laying and such.
Right.
That they can wait until taking in the sperm and fertilizing their eggs and such. They can control when they're breeding.
Yes.
But also, this is a mechanism that arthropods will often use for transferring sperm on land.
Mm-hmm, mm-hmm. This
is a way you can ensure sperm transfer if you don't have the benefit of internal fertilization or something like that. So this is another one of those where it doesn't have to be this. These are certainly features of the reproductive system that would feasibly work on land.
Yeah, make a lot of sense if they were going on land.
Both mating, the transferring of sperm, and egg laying, if you're controlling when eggs are being fertilized. And again, one of the main reasons why this has been suggested for Eurypterids is because horseshoe crabs do this kind of stuff.
Yes.
So it is completely familiar to us to picture these kinds of animals crawling out of the sea to mate in nice sheltered beach environments or things like that. That being said, whether they actually did this or not is hard to say. There are hundreds of species. It's possible some of them were doing something like this and others weren't. So it is at least in the realm of possibility that they could have been land reproducers.
Well, and you making the point of this comes up because we have modern relatives of this group that are doing stuff like this is both a good reason to consider it, but also is one of those instances where, as scientists, we have to be careful on, are we more focused on this idea because we have something that has brought our attention to it that is not actually a Eurypterid. It's not a Eurypterid. It's not connected to them directly. So
are we getting distracted by this cool example?
Are we chasing this rabbit hole farther than we might have if we didn't have horseshoe crabs today?
Right. So what we can say scientifically is that it's possible.
Yes.
And I would even go so far as to say, given how abundant and diverse these animals were, I'd be a little surprised if there weren't any that did something at least similar to that.
We have fish that come out of the water and walk around.
Right.
This is a group that already has legs.
This group has legs and they can actually breathe in the air.
So it would be kind of weird if none of them were like,
Now, these questions are interesting for our understanding of Eurypterid biology, but also often when this comes up in studies, researchers are additionally trying to learn about chelicerid evolution. The questions about how Eurypterids were breathing or reproducing or transitioning onto land, evolving features that allowed them to move onto land, are often used as examples for how early chelicerates might have been, because we know that a lot of other chelicerates moved from the water onto land. That's how we got spiders and scorpions. Horseshoe crabs live in similar ways. So Eurypterids are often studied in these regards, not only as let's learn how Eurypterids live their lives, but let's learn what sort of features were present in the early evolution of the chelicerate group, because that might help us to understand the ancestors of spiders and scorpions and horseshoe crabs and things like that.
Yeah, the groups that remain.
Yes. So understanding how Eurypterids might have moved onto land can be informative for understanding how spiders moved onto land, things like that.
Because it's not necessarily that their ancestors would have gone through the same steps, but very, very likely there would have been at least parallels.
Yes. Again, you mentioned book lungs versus book gills. Yeah, they're working with a lot of the same tools. Also, since we're talking about reproduction, I just have a very short note here. But we do actually have a bunch of Eurypterids species where we know a lot about their ontogeny.
Ooh.
How they grew up throughout their lives. Eurypterids went through instars, which is what we see in a lot of arthropods today, different stages of development. And a number of species are known from many instars.
Cool.
We have a bunch of young to middle to old Eurypterids. Eurypterids, it seems, went through direct development, more or less. They were not metamorphosing or anything particularly dramatic. They seem to have started as little Eurypterids and then went through many instars, molting along the way, like spiders, like scorpions.
Yeah,
molt.
I was about to say, to my knowledge, that's how all chelicerates grow today.
That's what I thought.
Yeah, is they just molt and become bigger. Like, as a baby, they look like what they will basically look like, and then they just get bigger.
And of course, there is one other major feature of the Eurypterid lifestyle and ecology to discuss, and that is their diet.
Yeah, what are they eating?
I mentioned way at the top that Eurypterids are generally considered carnivores.
Which, I mean, other than horseshoe crab, I think all arachnids, so
Yep.
that's also a widely chelicerate thing.
And also just aquatic arthropods in general, like crabs, lobsters, shrimp. They are often eating other organisms. They're
Very
also
true.
eating other animals.
Yeah.
Most Eurypterids are generally thought to have been either swimming hunters, so swimming in the water column, chasing down prey, and or, because they could have done both, crawling predators / scavengers. That they might have been crawling along the sea floor or the lake bottom or whatever, grabbing prey. They might have been swimming after prey. They were probably scavenging. There's just all sorts of detritus on the floor. But carnivorous, eating other animals. Signs of predatory lifestyles are abundant. Many Eurypterids were relatively large, especially compared to other animals of their times. They were active swimmers. Also, Eurypterids are often interpreted as having stereoscopic vision.
Oh, cool.
They had overlapping visual fields, which is a thing we see in predators.
Yep.
They had predatory vision.
So they could lock onto their prey.
They often had spiny legs, which are good for grabbing at food. Eurypterus, the famous, extremely common one, is often labeled as a generalist. Eating lots of stuff, whatever it can get, like those dinosaurs we were discussing, a foundational carnivore in its ecosystem. You put something in front of it and it might have gobbled it up.
Yep. Which, yeah, no, that's also a very arthropody.
However, in terms of direct evidence, there is very little. I found multiple references that said that there are no known gut contents for Eurypterids. There are some potential coprolites, so fossilized poops, that have been assigned to maybe being Eurypterids, that have contained fragments of fish and trilobites and other Eurypterids. It is absolutely considered to be most likely that Eurypterids were occasionally preying on each other. One piece of evidence that has been put forth for this is that many Eurypterids, the positioning of the eyes is interpreted to be good for spotting predators. Mm-hmm. And they are good swimmers, which means that they are good for escaping predators, especially when they're young. And in many of the ecosystems, the fossil sites where Eurypterids like this are found, the only larger predators around were other Eurypterids. So they were probably eating each other as well.
Yeah, we can't figure out who else you'd be keeping an eye out for.
So a lot of Eurypterids were some active predators, others sort of more generalistic. And then there were certain Eurypterids that had specialized into a type of feeding behavior called sweep feeding.
Ooh.
They had specialized appendages. Often, I believe these were the chelicerae, with lots of projections that made them comb-like. And they would sweep those appendages through the water or through the sediment. Mm-hmm. And little things would get caught in the combs, little crustaceans and worms and things like that, tiny, tiny things that they would then just gobble up out of their comb appendages.
Yeah.
One study that I saw from 2021 specifically looked at a Eurypterid named Certoctenis, which they described as the most specialized sweep feeder. Its comb arms were adapted to be able to collect plankton-sized prey.
Wow.
That this was kind of a filter feeder.
Yeah.
Like collecting, they described it as mesoplankton.
Okay.
So, middle-sized plankton, not the tiny, tiny, tiniest stuff, but collecting plankton out of the water column or the sediment and eating that.
Cool.
So still carnivory, that's still a form of predation, but their Eurypterids varied from having small mouth parts and legs to collect small organisms, having comb-like mouth parts or comb-like appendages to collect tiny things, to some that had just pincers for grabbing food.
Very, very cool.
So there was a variety of dietary styles.
Well, and this is from a time where, as noted by the fact that the largest Eurypterids got to be bigger than either of your current hosts of this podcast, that we have an aquatic ecosystems where arthropods can be the top of the food chain and all the other stages down
to 2 centimeters. The smallest Eurypterids would have been caught in those comb.
Yeah.
That's actually big.
Yes.
I remember that study actually did say they were measuring things in millimeters.
Okay, yes.
So not quite that small.
Maybe the babies.
Sure, yeah. The larvae.
Yeah. But
they could occupy all these different niches in their habitats.
And so it's a weird combination that some of the things you're describing seem very familiar, like scuttling across the sandy bottom and just picking up what you find. That's very horseshoe crab. That's very crab. That's very lobster. Yeah. But then pursuit predator arthropods in the water, that's not other than boatmen and water beetles, I can't think of a lot of I'm going to chase you down.
Now, I should clarify. I don't know how much chasing they're doing.
True.
I don't want to depict them as sharks, high speed chases, but good at swimming, grabbing stuff out of the water column. I don't want to make it's not like a James Bond movie.
Yeah,
necessarily.
They're jet fighters.
Right.
No, that is a very good point.
But they are swimming and grabbing stuff out of the water column. And if not pursuing prey, certainly instigating prey to flee.
Yes. It is weird how a lot of the behaviors feel very familiar, and then others are things that it's kind of hard to picture an arthropod doing.
Yeah.
Because in today's ocean, they really couldn't do that.
And speaking of stuff that's kind of hard to picture, I would like to take a little bit of time here at this part of the episode to discuss giant Eurypterids.
Yes.
What were they? How were they different? What do we know about the giants? Because like I said, these are the biggest arthropods that have ever lived. Insects haven't gotten this big.
Nope.
Insects have done everything.
Yep.
And not horseshoe crabs, not spiders, not scorpions. These are the record holders. And not only are Eurypterids the record holders, multiple lineages of Eurypterids reached giant sizes of estimated 2 meters or more. There were multiple evolutions of 6, 7, 8 foot long Eurypterids. The most famous of these groups are the Pterygotids. The Pterygotidae, which includes such famous genera that you might even have heard of as Pterygotus, Eretopterus, Jekyllopterus. That last one is the one I mentioned earlier that is often cited as the big one. Pterygotids were, just in general, very speciose. There are many species known from all over the world. They lived during a relatively short time period from the Silurian to the Devonian. If I remember right, it's 40 million years that they existed. And they are found worldwide.
Okay.
So I mentioned earlier that it's been suggested that Eurypterids might have had to disperse along shorelines, not crossing open oceans. This is one group that has been suggested to possibly be an exception. Some of these might have been strong enough swimmers to cross oceans and disperse that way.
Which makes sense. Big ocean animals are good at that.
They sure are. The big Pterygotids were also specialized predators.
Yeah.
They were strong swimmers. They have big swimming appendages. They tend to have a flat telson way down at the end, a paddle-like telson. Their visual system has been compared to modern predatory arthropods, that they were seeing the way that predatory arthropods do today. And their most famous predatory feature, their chelicerae. This is the group, the pterygoid Eurypterids, where the chelicerae are just big honkin' claws.
Yep.
They have developed these big pincers with teeth on them.
Yeah.
Like if you think of a crab, like crab claws have those little points, those denticle type things. Scorpion claws will often have this. Pterygoids evolved that too. Toothy claws coming off of their face.
Which is both so cool and so intimidating.
Yeah.
When you get a look at them.
And these, I've seen them described as specialized for crushing.
Oh.
More than for slicing. A lot of the smaller Eurypterids had more slicey claws. The big ones, at least some of them, seem to have had crushing claws. Again, like a lot of crabs will often have those big, robust claws for crushing stuff.
Absolutely. And it makes sense if your little ones are just taking apart stuff to get it into their mouth. And these are killing things.
Yes. And these are at the end of flexible appendages. They're not arms, but the chelicerae are flexible appendages that are a shape and style that has been described. I love this word. Every time I see this word, I'm excited about it as raptorial.
Yes, I was so hoping that's what you're going to say.
Like a praying mantis.
Yes.
They are reaching out and grabbing stuff into the conveniently nearby mouth.
And comparing it to praying mantis, how quickly were you grabbing stuff? Like, was it a strike?
Yeah.
Oh.
I would assume they were a lot like crabs.
Yes.
Or lobsters.
Mm-hmm.
Reaching out and grabbing things. Probably faster than a lot of their prey was able to do anything about.
Oh, yeah. Like, there are some crabs that if you're not careful, like, they can get that claw where they want it to be pretty quick.
Somewhat unsurprisingly, the claws are the most commonly fossilized and found parts of pterygoids. They are often identified by claw remains because the claws are big. They're also thick.
Yeah,
they're tough. And indeed, it was a 2008 study that found a partial claw of Jekyllopterus from the early Devonian of Germany. This is the study that I believe, at least it's the one I've seen cited, as providing the big size estimate. This was a claw whose full length would have been 46 centimeters. That is 1.5 foot of claw.
What?
For a total specimen that is estimated to have been up to 2.5 meters long. I have seen some places that cite estimates even bigger than that, but I didn't see that in any of the papers I read. So Jekyllopterus is estimated to have grown, the largest of the pterygoids, 2 meters, possibly up to 2.5 meters long. That is an 8, maybe 9 foot long arthropod.
Like, that's now something that I'd be afraid of being in the water with.
Yeah,
like,
that'll get you.
It's not probably going to hunt me, but it could send me to the hospital.
Oh, yeah. Yeah, you're going to lose something.
Yeah, it's going to take a toe.
And these were not, like, big herbivores.
No.
These were giant predators. These would have been some of the most intimidating animals in the Silurian Devonian seas, and not the only ones. There is also the genus Carcinosoma, which is a separate lineage of the swimming kind of Eurypterids. Carcinosoma has been estimated to grow over 2 meters long. Mm-hmm. I've seen 2.2 cited. And I've seen this one described as likely hunting along the sea floor. It had spiny appendages that it might have used to trap prey. And then there's the other major group. We've got the pterygoids, which is a major group with famous large ones. Carcinosoma, which is another genus that seems to have gotten big. And then finally, the Eurypterids.
Good name.
These were styloneurines. Oh. So the walking style, as it were. The largest of this family was Eurypterys, estimated up to 2 meters long. These were freshwater sweep feeders.
Weird.
These lived in terrestrial, freshwater continental environments with the sweepy appendages. And these were later than the pterygoids. These are found Carboniferous to Permian. They have, not only are they doing the sweep feeding thing, and not only are they living in a slightly different habitat, but this group has a lot of evidence suggesting they might have moved around on land. I mentioned those trackways earlier. Mm-hmm. The Eurypterids often have bigger, stronger legs. They have a thicker cuticle.
Okay.
So just their body wall is stronger. I've seen some citations for potential evidence of a stronger respiratory system, that they might have been more powerful breathers, I guess, to put it in a weird way. So this group of giant arthropods were sweep feeding on lots of tiny, tiny things, but also possibly good candidates for venturing out onto land.
That is... I can't put my finger particularly on why, but that feels so much more utterly alien.
Yeah.
Of, like, the idea of a 8-foot-ish arthropod swimming around the ocean is like, that's big and that's intimidating.
Right. But that's where things like that belong.
Yeah, like...
in the ocean where things are too big and too weird.
We've still got giant aliens with squids and stuff in the ocean today.
Yeah,
so,
absolutely.
Like, yeah. But, like, the idea that I could be walking alongside a lake during this
Scotland.
time. Yeah. Mm-hmm. And then scuttling out could be the comb-faced arthropod to go to another lake.
A 2 meter, just coming up. And if we're right about our other suggestions, several comb-faced 2 meter long arthropods coming up to transfer their sperm packets.
Yeah. Like, you would just come across a assemblage of these that then just scuttle back into the lake. And it also makes me feel like they're the Eurypterid manatee, because they're not crushing and they're just scooping up little organisms.
They kind of have a similar to, we've talked about the biggest whales, the biggest sharks are filter feeders.
Yes.
These are doing a very filter feeder style of predation, scooping up really tiny things.
But in lake, this is so weird. Yeah, this is so weird.
They're so good. So Eurypterids and pterygotids both interpreted as getting very big. Pterygotids seem to be the ones that got the longest.
Yeah.
But I have seen it pointed out that Eurypterids were probably heavier.
Yes.
They were more strongly built. They were more thick and robust organisms. So those would have probably been the weight record setters.
Yeah, the most massive Eurypterids.
Yes. And not only did multiple lineages achieve this, but multiple lineages at different time periods in different habitats and living different lifestyles, feeding different ways, eating different food. So this is a trend that we've seen a bunch. We've seen this in dinosaurs. We've seen this in mammals, where you have a group that multiple times and in multiple different ways achieved being preposterously large.
Yes. Which always then brings up that question again of, why don't we see the similar things in the similar groups that are around today?
Yeah.
And is it that there's something different about the anatomy? Is there something different about the time?
And I'm so glad you asked this question, because the last thing I'd like to do in this episode, now that we've kind of we know what Eurypterids are, we have their anatomy, their lifestyle, I'd like to go very briefly through a history of Eurypterids.
Perfect.
Just their evolutionary story. It's not very long. We don't have a ton of details, especially about the origins and the ends. The earliest Eurypterids, as I mentioned, come from the middle and late Ordovician, so 470 million years ago or so. The origins of the group are unclear. There have been some proposed Eurypterid remains from the Cambrian earlier, but these aren't definitive. It doesn't sound like these are agreed upon. The 2015 study I mentioned earlier that identified the oldest known Eurypterids, this is from Iowa, Pentacopterus. That study pointed out that the earliest known Eurypterid, is from a branch of the Eurypterid family tree that is a later branch. It's a more derived clade, which suggests that the other branches would have already split off by then.
Okay.
So it's possible that they had a radiation in the Ordovician, or that they had already been evolving for some time, and there are earlier Eurypterids that we just haven't found yet.
Yeah.
That they could have been back in the Cambrian or earlier in the Ordovician. And really, considering that everything showed up in the Cambrian, I wouldn't be surprised if someday we find a Cambrian Eurypterid.
It would make a lot of sense.
But as of right now, we don't. Like I said earlier, they don't actually have a great fossil record outside of specific really nice sites. So Eurypterids kind of show up.
Yeah.
They are Eurypterids from the start.
Which is one of those weird combinations of, when we have their fossils, we get really good information, good preservation and varieties. but we don't actually have a great record overall.
Right.
So it's a weird combo.
It's a strange one.
There's a lot of stuff we know and a lot of stuff we don't know.
Following the Ordovician, Eurypterid peak diversity is in the Silurian and Devonian.
Mm-hmm.
This is where we see the most widespread of the Eurypterids, the most diverse, the most numerous. This is where we see the genus Eurypterus, the one that is almost all of the Eurypterids. These are only found in the middle to late Silurian of Euramerica, the northern continents, but they are extremely common and well known. So Eurypterids were just all over the place during the Silurian Devonian. This is also where we see the rise of the pterygoids.
Okay.
The predatory giants. Pterygotus and Jekyllopterus are Silurian to Devonian.
Well, there's so many Eurypterids for them to eat.
Yeah, there's a smorgasbord. Toward the end of the Devonian, and the late Devonian, and particularly by the end of it, Eurypterids decline. They are on the downswing in the late Devonian, especially Eurypterina, the swimming forms in that group, including the pterygoids. The big predatory ones decline and disappear during the Devonian, and it has been suggested that this might be related with the fact that this is a time where we see a lot of diversification in fish.
Yes.
Particularly armored fish, placoderms, episode 29. So you mentioned just a little while ago, why don't we have these big predatory arthropods? Well, it could very well be that the ocean became full of fish and placoderms and sharks, and that they outcompeted those big predatory arthropods.
That fish are just a little bit better adapted at being a swimming predator than arthropods, at least arthropods that we've seen thus far.
Yes.
Could be.
Now, Eurypterids did not all go extinct during the Devonian. After the Devonian, there are 3 major groups that survive, all of which are freshwater.
Oh.
The Eurypterids seem, after the Devonian, Eurypterids seem to be mostly or entirely out of the sea.
Oh, wow. They got evicted.
They did. They got all kicked out. There are 3 major groups that remain. One is a swimming group, Eurypterina, the genus Adelophthalmus. The other 2 are Styloneurina, the quote-unquote walking Eurypterids, the Micteroptids, which were small freshwater forms, and the Hybridoptids.
Okay.
The other big group, or group with big ones in it, that were the big sweep-feeding freshwater Eurypterids. So we had big ones in the brackish and sea and everywhere that disappeared during the Devonian. And then after that, Carboniferous Permian, the next group of big ones was able to persist. And this also goes back to the question you asked, because it's important to remember that at this time, there wasn't a ton else on land.
Yeah.
Now, once we get into the Carboniferous, certainly we start to see lots of amphibians and early reptiles and things like that. But this is another case where it's possible that once land organisms, once vertebrates especially, took over land ecosystems, there just wasn't space left for big freshwater Eurypterids to be hanging out.
Well, and they're an interesting scenario where they could have been pushed out even by smaller things if there were other things feeding in the sediment better than them and taking up all that food that they were trying to sift out or something. Like,
yeah,
they might not have been able to compete.
And then, of course, there is one other thing to consider. Eurypterids, the freshwater Eurypterids after the Devonian survived through the Carboniferous, and they survived through the Permian.
Oh.
And there are many reasons why the Eurypterids might not have survived in those land ecosystems, but one of the reasons seems to be the Permian extinction.
Yeah, I was about to say, something happens at the end of the
Something
Permian.
happens. That 2021 study I mentioned earlier that identified the latest known Eurypterid, these are partial remains of a large freshwater sweep-feeding Eurypterid, one of the big ones, from Queensland, Australia, which is a weird place to find Eurypterids.
Cool.
Which has been identified as the Micteroptid, potentially Woodwardopterus, or something similar to it. This is one of the walking ones, not the big Hybridopterids, but another member of the walking group. These remains have been estimated to date to 254 to 252 million years old, which is right before the Permian extinction.
Okay.
So if these are the very latest remains of Eurypterids that ever existed, then they petered out just before the extinction. More likely, they were around to some small degree right up to the end and were taken out during the Permian extinction.
They got to experience it with everyone else.
Yeah, like trilobites.
Yes.
They were kind of on the decline. They were shrinking and dwindling, and then they got to the end of the Permian just in time to be wiped out by the worst mass extinction event that the world has ever seen.
I wonder if they had any feeling like, this seems like overkill. For
Listen,
where we are now.
We were on the way out.
All right, calm down.
We just wanted to see some dinosaurs.
Yeah,
you can't give us that.
Rude.
Listen, Eurypterids, you didn't want to make it to the Triassic. Trust me. There were spawning grounds of 50-foot-long ichthyosaurs. That is not where you wanted to be. I know you were the big guys around. You were 2 meters long, and you thought you were on top of the world. But aren't you glad you didn't see it?
Yeah, no, that's a horror story they didn't know to expect.
I love to imagine, just like we're sitting here being like, can you imagine a 8-foot-long arthropod crawling out of the lake? How ridiculous to just go back in time and tell Eurypterids about the future, and they'd be like, I'm sorry, what? A 50-foot-long, shaped like a shark? What's a shark? Yeah. What does that even mean?
Stop making up numbers. Numbers don't get that big.
They had their heyday. Mm-hmm. Eurypterids were some of the most successful and impressive predators that the planet has ever seen. Like, these were apex predators in probably most of the places they lived. By the end of the Paleozoic, they had gone the way of the trilobites and the placoderms and all those other cool extinct Paleozoic groups that we now can only look fondly back upon.
And they, as many do, but Eurypterids fall squarely in that group of, man, that's a bummer.
Yeah, they are so cool. We will have, as we always do, a blog post on our website, which is now commondescentpodcast.com. How about that? Got around pretty fancy. We're moving up now. It took us 6 years, and we finally did it. In that blog post, there will be links to all sorts of more information, to some of the studies I've mentioned, things like that, but also pictures. We'll put some pictures. We'll find some nice free use imagery. And then I also encourage you to just start Googling Eurypterids to find the images that we can't use on the blog post. But they are so cool looking. They're so striking. Their fossils are beautifully preserved, and they are just a fascinating group of, or like trilobites. We have done the general overview, but what a cool! These are some of paleontologists' greatest hits.
Oh yes,
like Eurypterids, so cool, such cool. I will continue to call them sea scorpions, but hopefully now everybody here listening understands why sea scorpions. It's a good name because it's very catchy.
Yes. And it gets you it is a multi-legged,
putting you in the right direction
with a long back end. You're in the right ballpark.
Right. But they're not scorpions and they're not all sea.
Yes.
But they are very cool.
Well, they fall into one of the groups of animals that feels like it was drawn for a video game or for like if this one crawled out of in the new Avatar movie, I wouldn't be surprised. It's like, you look cool. Like, just objectively, you look like you should be made into toys for me to play with in the bath. Like, you just look cool. And then they are so diverse and interesting. And I didn't know there were filtery feeding ones.
Me neither.
That's super weird. And they got big. That's super weirder. They're so cool.
Yeah. Dear listeners, if any of you out there happen to know things about Eurypterids and you have a favorite Eurypterid fun fact that we didn't mention that you think would wow us, tell us.
Yes, please.
Send us some info. We'd love to learn more about these weirdos. That's where our discussion for this episode is going to end. Like I said, check out the blog post if you'd like to learn more. Before we go, just like last year, we're going to end this episode with a patron question. One of the things that our patrons are able to do at a certain level on our Patreon is submit questions for us to answer right here on the podcast, right into with everybody can hear it. Will, what's our patron question?
Our question is from Samuel, who asks, what the heck are vetulicolians? according to the most recent research.
That is a great question, Samuel. I think we can all agree that we wonder that question.
This is the question that keeps me up at night.
What the heck are vetulicolians? So, vetulicolians are a group of strange Cambrian organisms. Speaking of weird Paleozoic things that there's not very much like today, this is a group of even weirder things. So, way back in the Cambrian, before any of the Eurypterids we know about, vetulicolians had this bulbous body that was sort of football shaped almost, with a mouth way up at the front and then a segmented tail like section that maybe it was using to swim around. They don't appear to have had appendages. They were very strange looking creatures. The reason I assume that Samuel is asking what the heck are vetulicolians according to the most recent research is because research has gone back and forth on what these are, where they fit on the family tree.
Who should be saddled with them in their branch of the tree of life?
Who has to sit with the vetulicolians at the holidays? For a while, it seems, they were considered arthropods or close to arthropods, but more recent study considers them to be deuterostomes, which is the group that includes echinoderms, so your sea stars and urchins and stuff, and chordates, vertebrates and things like ourselves. So it's sitting at our table at Thanksgiving.
Also,
unfortunately.
How weird do you have to be able to be confused between our group and arthropods?
To be fair, this is Cambrian, where everything was weird and different, but also you're not wrong.
Yeah, we were at the time where all of the branches of our current understanding were branching from each other. Yeah. But still.
This is the kind of thing. So the studies that have linked it to deuterostome, so there's like 15 genera in this group, vetulicolians. There's a whole bunch. The studies that have linked them to deuterostomes are looking at the specific features are certain features of the gut and the presence of what appears to be a notochord.
Gotcha.
That's how far back we are. As we're saying, you have a spinal cord-like thing that seems to link you to chordates.
Yeah. Which, I mean, it's still a weird shape, but
it's a little fish-like, though.
I can see a cord there and a fishy front and back shape.
It looks a bit like the early jawless fish, where you had a bulbous body and then a paddly tail.
Yeah.
Kinda has that thing. Now, these are not fish. They are not even close to fish. But they've got sort of that chordate body plan kind of going on.
Well, I can see where similar body plan, similar features could find their place in that anatomy.
Yes.
So I can see how you could have a relation.
So the most recent research links vetulicolians to deuterostomes. They are within deuterostomes or close to deuterostomes, possibly close to chordates, but certainly deuterostomes at the very least. So cousins-ish of our major vertebrate lineage and echinoderms. However, the reasons that it has been so difficult to nail them down, as a 2018 study very helpfully described for me. Number one, there is no clear consensus on how to interpret their anatomical features. So sometimes we look at the guts and we say, those look like deuterostome guts, but not everybody agrees with that. That can be very hard to determine. Number two, I'm just going to quote this line. Their disparate morphology might even cause one to question whether this is a monophyletic taxon. A bunch of things that have been identified as vetulicolians have later been re-identified as something else, so they might not even all be the same group, which can be confusing. And number three, there are certain species from the Cambrian that vetulicolians are often compared to say, well, they are similar to X, and that makes us think that they might be deuterostomes. But in many cases, X is also not agreed upon I saw it multiple times when I was reading about them, where I'd see a citation that said, vetulicolians have been linked to this other organism, but some authors have suggested that that other organism isn't related to chordates.
Yep.
Because it's the Cambrian and it's so weird. There's so much, everything is so weird and unfamiliar and simultaneously looks so similar to each other.
Yep.
That it can be very difficult to determine where anything actually goes.
Yeah, well, they're all very different from the things we know today, but all of those very different forms have a lot of overlap between each other.
Animalia had not differentiated very much at that point. So to answer Samuel's question, what the heck are vetricolians according to the most recent research? I think has two answers. One, deuterostomes. Mm-hmm. They are within or very close to deuterostomes, echinoderms, chordates, and our cousins. And number two, maybe. Maybe they are something else. Who knows? It's gone back and forth quite a bit. Who knows what the next vetricolian discovery will tell us, that they were worms or something utterly weird.
And it's once again, it's like, I mean, I could see it, but that's not super unusual for...
Now, I guess I don't want to diminish the research that has been done.
No.
There does seem to be a consensus that they have a notochord.
Yeah.
So,
okay, that makes sense.
That's pretty good. But again, I only looked at a couple of papers. I did not do a deep dive into this. I don't know how much consensus there actually is, and I do not have any sense of the likelihood that next year we'll find something that points us in a slightly different direction. So... the short answer is, what the heck are vetricolians is a great question, Samuel. We also wonder, and so it seems, do scientists who study vetricolians.
I found out they were a thing today.
Yeah, me too. Anyway, that wraps up the episode. Thank you, Samuel, for that intriguing question. Thank you to all our requesters for spurring us to have a conversation about this most fascinating group of Paleozoic organisms. Thank you to all of our new patrons, old patrons, former patrons, upcoming patrons. Hey, that could be you. Yeah, I'm talking to you. Stay tuned. We've got more cool stuff coming all throughout the year. Hop down to the episode description in your podcast player or on the YouTube, wherever it is that you listen to our podcasts, for links to our Patreon and our social media, through our Audible link where you can get a 30-day free trial and learn about cool stuff. I don't know if there's any Eurypterid books on Audible. Probably not, but there might be other things that would interest you. Check out the blog post for links and pictures and more information for you who want to continue learning about Eurypterids. We release episodes every fortnight. That will continue this year. I think I said the same thing first episode of the year.
Oh, yeah.
Also this year.
Yeah. We decided. Again.
We're going to keep doing it.
We will renew our subscription to that schedule.
In the next month or so, we will be celebrating our anniversary. Mm-hmm. 6 years at the end of January. It won't be quite as big and exciting as our 5-year anniversary last year, but it's still coming up. Also, in a couple episodes, Darwin Day is coming up. We usually do an episode for Darwin Day, so that'll be fun too.
Yeah.
We hope you've enjoyed learning about Eurypterids. We hope you've all had a happy new year and a happy holiday season, or at the very least, a tolerable new year and holiday season.
Yes. We hope it was as good as it could be for whatever your situation was.
If you haven't already, check out our end of the year Q&A, which we released right at the end of last year. It's over 4 hours long. Tons of questions that we answered from our listeners. Tons of audio for you to enjoy.
It's a bunch.
And stay tuned for 12 months of more cool stuff. Bye.
Bye, everybody.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.